So let's just get started. And there can be, of course, different things, like maybe we may have excavation and then we will calculate the dry budgery. You can say that is just at the base. And then we may determine the number of pipes and, of course, the number of joints, okay? And then the final thing, which is actually the refilling, okay? And the refilling means just to fill these areas, okay? It is very simple thing without the pipe, okay? So refilling is must then. So what happens is actually I'm gonna start with even I can do this manually, but I think Excel can be a good way to do these things. Okay, maybe practically. So let me just confirm which way you guys want me to calculate these materials for the same sewer line. Is it Excel good or maybe just a manual calculation?
Sir, good. Excel is a good.
Okay. So number first, we have actually, and let me just have, let's say, serial number. Okay, these things I think must be, and then description we have, and then we may have number, then the length, then the width, okay, and the height, of course, or depth, and then the quantity, and of course remarks. Now, in serial number, we have first, that is, we will have actually an excavation, okay? And you can type many things related to an excavation, like maybe in ordinary soil, let's say up to 3.5 feet. And let me just read the text so you guys can see the whole thing. Now, a number, it can be only one because this is just a single sewer line. And another thing is actually the length. Length that is already known, which is 300 feet. Okay, you can see that in the terms. So I can put 300 over here. The width or breadth that is just known. You can see it. Okay, it is only 3 feet. So 3 over there. Now, the height, as you can see, it is also known, which is 3.5, okay, from the ground level, okay. We can just dig below the ground level. So it's very simple. So the height, that is 3.5. Now, what you have to do is actually you can just apply that formula, okay, like maybe the length, the breadth, the height, and so on, okay. So it is the same thing, like maybe the height times the breadth, which is actually the cross-sectional area, you can say. And then, of course, the length, and then, of course, the number of members, you can say, and press enter. So we have actually this. And let me just put another column over here, like maybe for the units. Okay, what do you say? Units. So we may have another column maybe for the units, and this is now in CFT. Okay, very simple. So now next, as you can see, we have another thing which is number two, and that is just actually the dry budgery, like that. And the n number, that should be one. Length is just the same thing. Weight is just the same thing. You can see this, that this is the dry budgery, okay? This thing, you can see it, okay? And of course, this is actually 9 inches, okay? The thickness or maybe the depth of the dry budgery, that is only 9 inches. It is not shown in the diagram, however, but that is 9 inches, okay? Don't be just confused with that. So the height that is just known, which is of course 9 inches or 0.75 feet, okay? Let me just write 9 inches over there so you guys can understand these things, okay? You can say this is just 9 and then inches. Now, we have the length, the vector, and then of course the height, and that should be actually, I'm gonna drag the formula just like little bit like this way, okay? And again, because we have 3 dimensions, so the unit must be in cube feet, okay? Now, another thing is actually the number of pipes. You can say number three, and that is actually the number of pipes. It is the same way as we do, of course, the calculation for the main bar or maybe distributions bar for a slab. Okay, and we have done that, of course, many times. Okay, so the number of pipes can be actually, we will put the formula over here. That should be the length. We can take this length or that one, does not matter because it is just a known thing. Okay, so the length, and we will just divide that by the length of one pipe, and that is of course 6 feet. Okay, the center. So we have actually 50 numbers, and in a quantity that is actually 50, we can put that over there, and of course the unit can be in numbers because the pipes are just, you can say, determined in terms of numbers. Now the number of joints, it can be actually just the same thing because of, you can say 50 minus 1. But why minus 1? Let's say 50, and then we will put the minus sign over there and 1, and which is 49. Okay, so the quantity can be 49 and the unit is post numbers. Why minus 1? Because at the end, when we dispose, you can say, or you can say at the disposal point, we don't actually join pipes over there. Uh, and if you don't understand, let me just draw something, if I can do it. Okay, let's say we have pipe, and let me just rotate this thing over here. Okay, let's say this is a pipe. You guys can see it. Okay, confirm it, please. Okay, so this is actually a pipe. Now what we do actually, we join these two pipes and another pipe, let's say, and so on. Okay, this is the same way we actually join pipes. Okay, now let me just have some okay, now here we join the start of the pipe with a main source, you can say. Okay, and then this pipe can be joined over here, okay, over here. And now let's say over here we have a main sewer, like you can say sewer line. So here we don't actually need the join, okay, because that is just you can say the end of the pipe. So at the end we may not have joints. That's why we are subtracting 1. Is that clear?
Yes, sir.
Okay. So the number of joints, that's just done. And the only thing which is remaining now is actually the refilling. Okay. We have to refill the same trench after digging or maybe after excavation. Okay. Because when we lay the pipe, of course, these empty spaces are then just filled again. So number 5, and it can be actually refilling of trench, you can say. And in number, it can be only 1 because it is just a single, you can say, sewer line. Length can be the same thing, which is, of course, 300. It's very simple. Now, what should be the breadth and then the height? It is, of course, the cross-sectional area. But remember one thing, to determine this cross-sectional area, which is the empty spaces, it is like very, you can say, a complex process. So the best thing is actually, we have already determined the excavation. So we will just subtract the volume of the pipe from the excavation. And of course, that becomes the refilling then. Okay. So that process or this way can be very short, you can say. Okay. Now, let's say I'm gonna erase these things and these. And if you remember the total excavation, that is just known. You don't have to write them again and again, does not matter. But the total excavation, that is over here, and that is known, okay? 3, 1, and 50, okay? And this is, of course, CFT. I'll just calculate the volume of the pipe. What do you say? Okay, so I can say that the pipe volume, and in number, I'm gonna have one pipe. I can even put 50 in numbers, but this time I'm gonna consider the overall length is the pipe length, okay? And which is of course just 300. You can say the overall length. Now the pipe width and then the height is actually something which you can say we can determine the cross-sectional area, because length, height times breadth, that is actually the cross-sectional area. But the cross-sectional area of a pipe can be actually pi d squared divided by 4. What do you say? Okay. So pi d squared divided by 4, we can put that formula over here. What you have to do is actually to have equal, and then you can of course use pi and empty brackets, you can say, and then d square. Now the diameter, that's very important thing, that is 11 inches. We're going to take the external diameter because the volume, or you can say the volume that is just occupied or taken by the same pipe is actually just involved. Okay, I mean that external diameter is just involved. Okay, I mean I'm gonna have the 11 inches diameter. Okay, and I'm gonna have the square for it. Now 11 inches is actually something like 0.9167. And I'm gonna put, you can say a square over there, and let's close the bracket. And now let's just divide this thing by the 4. Okay, let's rearrange the formula and Excel will do that for you. This is actually 0.66 something, okay? And this is the cross-sectional area. Now we will multiply this cross-sectional area with actually the length and then the number, okay? That is one, which is not necessary that much, but 198, that is actually the volume of the pipe, okay? And that is, of course, in CFT. Now, if you see the refilling, actually, the net refilling can be determined. Very simple. What I have to do is actually, I'm going to put a formula over here, and I'm going to actually subtract the pipe volume from the total excavation. This is the total excavation. We will subtract the pipe's volume and press enter. So we have actually something like 2,952. But one thing which is actually very necessary, and we will also subtract the volume of the budgery. What do you say? That's very important now. Because in excavation, okay, as you can see, the depth of excavation that is 3.5, okay, feet. However, over there, budgery's volume is also included. So let's just subtract the budgery's volume again, okay? And we will actually subtract the budgery's volume. And what's the dry budgery and what's it's over here, okay? So press enter again. And that is, of course, 2,277 CFT, the refilling work. This is very simple. Is there any question?
There are inches by meter, side is square divided by 4.
5d squared divided by 4 what?
11 inches का क्यों divided 9 inches का नहीं है?
11 inches, you can say that is in inches, but we're gonna put the video in feet. Okay, if you have calculator, 11 by, let's say, 11 by 12, that is actually something like maybe 0.916, and we have put it over here, 0.916. So 11 inches, that is the external diameter, which is actually in inches. But we will put that video in feet because the all other things, you can say other dimensions are just given in feet, okay? So that's the reason. Now these are actually different materials which are been calculated, and that's very simple, okay? Now another thing which is really important to note is actually, if you see the depth, that is 3.5 feet. So this is actually the mean depth. If you have different depths, maybe at start and then at the end, okay? Let's say if I can do it, let me have my pen, and let's say if we have something like this, where here we have this section, okay? And let's say this is maybe the same thing, okay? Here, if the depth is different, what do you say? Let's say if the depth over here is maybe 3 feet, and over there, if the depth is 2 feet, then actually you have to take the mean depth, which is over here. You have to sum these two, 3 plus 2, and you have to divide that by 2, which is actually an average video. So that's going to be 2.5 feet then. You don't have to provide 3 feet, okay, in the calculation, or maybe 2 feet. What you have to provide is actually the mean one. In the same example, as you can see, this 3.5, that is actually something which is the mean depth, okay? So we're here in excavation, that should be the mean depth only, I mean in the excavation, okay? So I hope that is clear. Now we will jump in to another example, which is going to be actually related to the, let's say we're here, this guy. This is just a manhole. Do you guys have any idea about the manholes? So let's say we'll try manhole in the same session. Okay, this is a manhole. You can see it. Its elevation, and you can say sectional elevation, and then of course the plan that is given. Okay, the manhole is 3 by 2.5, which is a rectangular manhole. We have actually the cover, which is 18 inches, and of course the slab that is 6 inches thick, and at the base we have 6 inches PCC work again, and of course the walls are 9 inches, and the depth that is also given. which is 3 feet, and 12 inches, you can say 4 feet. Let's just calculate the, you can say different quantities of materials for the same manhole. What do you mean by different quantities of material? It can be actually excavation for the same manhole, the concrete cover, the RCC work, I mean the concrete work, the RCC work, then the brick works. As you can see, we have 4 walls. Then of course there can be plaster work and staircase, which is also just over there. You can see that those are actually some steps, okay? So those steps can also be determined. And let's just do it. It's very simple. Now, there can be actually different ways to do it. You can also use maybe the same table, which is the description, number, length, breadth, etc. And you can use the direct mathematic formulas to work out the quantities of different materials. Okay. We will again use the same table because it saves much time. And in short time, you can actually determine many things. Okay. So let's say if we have excavation, the first thing. I'm not gonna provide much descriptions. You have to put actually all the descriptions from the specifications. Where here, I'm gonna put only excavation. Does not matter. Now, a number it should be 1 because it is just a single manhole. The excavation is actually the area times length. The length, what should be the length? As you can see in the same diagram, that is actually 3 feet. Okay, let me just have some pin. So this is 3 feet over here. Okay, this 3 feet. Now, the length which I'm gonna take is actually, we have this 3 feet over here, and we will add one thickness of wall for one side and for another side. It means 2 times thickness of wall for one side and another side. And then of course, this 6 inches stiff for one side and another side. So it means the length can be now, okay, if I'm not wrong, the length is 5.5 feet. Let me just have that. If you can, let's say the length is just the same thing, like maybe let me have my pen so you guys can see it. Okay. Now, the length is actually dead 3 feet. Okay. Dead 3 feet plus 2 times wall thickness, which is actually 9 inches plus 9 inches. And actually, dead 6 inches for one side and another side just for those tips, you can say. Okay. So 6 plus 6 inches. So it becomes actually total is 5.5. Very simple. If you have any question, you can ask me, of course. Now, we have actually the weight or maybe the breadth, and that weight should be, if I'm not wrong, that should be actually 5 only. Now, how 5? Let me just do it again, okay? As you can see, we have something which is actually, and I'm gonna change the color so you guys can, as you can see, we have 2.5 inches, okay, is the weight. You can see it. And now we will actually add 2 times the thickness of the wall for one side and another side. And then of course those 6 inches things, okay? That's gonna be actually 5. Now the depth, what should be the depth of excavation? As you can see, the ground level that is known over here. And from that ground level, actually below we will dig. And that's actually 3 feet, you can see it. And then of course the 6 inches thickness for the PCC work. The total can be 3.5. So the depth is actually now 3.5. And the quantity is just the same thing. Okay, you have to multiply all these things. Very simple. And press enter. As you can see, the unit is actually CFT. Now in remarks, you can put all these things like maybe what's 5.5. Okay, that is actually something like maybe 3 feet plus 0.75 for one side plus 0.75 for another side plus 6 inches, which is 0.5 actually for the one step, or you can say for the one side, and then 6 inches again, which is 0.5. Okay, so this is actually the remarks. You can put that maybe for the detailing. Is it clear or not? Where are you?
Correct, yes, sir.
Yeah, 5?
Yes, sir.
Okay, let me just make it little bit, you can say bigger so you guys can see it. Okay, as you can see, we have actually 2.5, which is actually the breadth or maybe the width, जो कि चौड़ाई है. Now, okay, look at to the cursor, okay, very carefully. This is actually 9 inches wall thickness, and for the other side, 9 inches wall thickness. That means 9 inches and 9 inches for both sides. With what? With 2.5.
Yes, sir.
However, that stiff, that is also 6 inches for one side and another side. Look at the cursor carefully. So we are adding actually 6 inches steps, which become actually total is 5.
Yes, sir.
Okay, I think it's clear now. Now, excavation is just, you can say, been covered. And the next thing is actually, let's say, number two, and that's PCC. You can say that is 6 inches thick. Okay, so let's say PCC, which is 6 inches thick. You can there can be actually maybe the ratio for that, and you can just provide that in the description from the specifications. Okay, and number it should be 1 because it is the same thing. Okay, the manhole is just 1. The length will be just the same thing for the same PCC because what we have actually dug in excavation were there in the same area we will actually provide PCC. Okay, so PCC pavement can be just you can say placed over there. But it can be just the same. However, the thickness can be different. As you can see, that is only 6 inches. Okay, so it means 0.5 only. And let me just drag the formula for the same cells. So 13.75, that is just the PCC work. Very simple. Another thing is actually, you can say, if you just consider the triangular portions, okay, in the same diagram, you can see, you can see these triangular portions, okay, we're here, this triangular portion, and we're here, this triangular portion. This is also, you can say, PCC work, okay, in floors, you can say. So in the description, let me just say we have PCC work in floor. And then this is actually number 3. Okay, and number, it should be only, you can say 1. Of course, those triangles are 2, but I'm going to consider that as a rectangle, okay? Because I'm going to keep one triangle upon another, you can say. So from those two triangles, I'm going to make just a rectangle. That can be actually, if you see the, it is just inside the walls. So the width that is actually 3 feet. You can see that. And the breadth actually that is just 2.5. However, if you see the thickness, that is something very different. As you can see, we have 3 inches thick PCC. It means the perpendicular of the triangle that is actually 3 inches. However, the other side, which is you can say below the pipe, that is 0. That is very 0. You can see that. If you are talking about only one triangular portion, then of course you can take 1.5 as the breadth or maybe the length. This time we have taken overall, so it means 3 feet is just taken as the length. And the depth, okay. The depth is, of course, you can say different thing. We have 0 and then 3 inches. So I'm gonna have an average video for that. Okay. So for the average video, let's say we have 3 inches or 0.25 in feet, you can say, and then we will add 0, which is nothing, you can say, and let's just divide the same thing by 2 to have the average video. Okay. Now, of course, we will just drag the formula below so we can have the quantity for the same work. And this is going to be in CFT. All right. Now, next, number 4. Number 4, as you can see, we will just determine the RCC slab. Okay. And then, of course, we will do calculation for the walls. So let's say RCC slab. Now, it should be 1 in number and the length. As you can see, the RCC slab that is just overlapped, you can say, on the walls. So the length for the RCC slab can be 4.5. And how? I'm gonna just have, let's just draw the same thing. Just look at to the section. We're here, this length, that is of course 3. Now, add the thickness of wall for one side and another side. So that can be 18 inches or maybe 1.5 feet. So 3 plus 1.5 feet, that is actually 4.5 feet. It's very simple. We have done that. We're here. All right. Now, what should be the width or maybe the breadth? That is, of course, 4. How? As you can see, this is actually 2.5. Okay. And now we will add 9 inches for one side and 9 inches for another side of this slab. Because the slab is actually just the same thing as this one. Okay. As you can see, I'm just drawing the green rectangle. So this is the slab. And we have to actually take its area. Okay. So now what should be the thickness? Of course, that is just given over there. That is 6 inches. So the depth is 6 inches, or you can say the height is 6 inches. And that's 0.5. 6 inches means 0.5. Okay. And let's just drag the formula and of course the unit. So we have actually the slab, and that is RCC slab, which is 8.12. However, in the slab, as you can see, we have manhole, you can say that one, or you can say the cover, manhole cover. So we will subtract that cover. It means the detection for cover, or let's say simple, manhole cover. Now, the detection is just going to be only one, because we have only one manhole. And now what should be the length and width, etc. Of course, that is just, you can say the diameter is given. It means it should be circular. I'm gonna have actually the area, and of course the thickness is going to be the same, but over here, the length and width, I'm gonna just merge those and center them maybe. And then let's just provide the same formula. Okay, pi d squared divided by 4. So we have pi. You can put actually pi or maybe the total video, does not matter. So pi, and then we will have actually the diameter, and the diameter that is 18 inches, which means 1.5 feet. Let's have its square, and we will close the bracket and of course divide by 4. That's okay. Which is 1.7 is the area, and you can say the top or maybe the base area, and we will multiply that with the thickness so we can have the volume. Okay, equal the thickness and then the area, and then of course the number. We will multiply these three so we can have the volume in CFT. Now, what should be the net RCC work per slab? We will actually just subtract the manhole. Very simple. And let's just provide the formula. And we have the total, you can say RCC work, which is 9. And we will subtract this deduction and enter. So 8.11 something, that is in CFT. We have this is the RCC work, you can say. All right, what should be next? Maybe you can say the brickwork for the walls. This is the final thing. You can say this portion. You can see it, this portion, okay, which is just, you can say yellow marked. So this is our brickwork. And this is the same thing. If you remember, we have done this for a single room, okay? We have done it before. You can see this, okay? These portions which are just been shaded with yellow and red color, this is actually the brickwork. So we will do this with long wall and short wall method. And of course, the height is just on the 12 inches and 2 feet, sorry, 3 feet, okay, which becomes actually 4 feet overall height, okay. So we will actually take 4 feet for the same wall as height. Let's just say we have number 5, and that's the brickwork. And now in the brickwork, we have actually long wall and then short walls. Long walls are going to be 2, short walls are going to be 2 again. And let's say the long walls, and let me just change the color. So you can say these are the long walls, you can say, okay, this portion, these are the long walls, you can see them. And for the bottom one, like this. So these are the long walls. And what should be their length? Of course, these 3 feet. And we will add, you can say the thickness of wall for one side and another side. Okay. So we may have actually 3 feet and then 1.5 feet, which becomes 4.5 feet. Let me just put those videos over here. Maybe for the long wall, the length is just 4.5, and its width can be actually 0.6. 2.75. This is only 9 inches. Okay, you can see the walls. Those are just mentioned over here. These are 9 inches thick walls. So I'm gonna put 0.75. And then of course the height, that is 4 feet, if you remember. We have already discussed that few seconds ago. Okay, so 4. Now the quantity, we will actually copy the formula over here. So that's 27 CFT. Okay, these are the long walls. For the short walls, the length remains the same, which is 2.5, okay? 2.5. The breadth is just the same, the height is just the same. We will drag the formula and of course the unit. The total brickwork is going to be now the summation of the long wall and short walls, okay? We will sum these two, which is actually 42 CFT brickwork. Very simple. So this is what we do, and actually this is how we determine the quantity of brickwork, okay? Only one thing is remaining. You can say two things, which is actually the internal plaster, and then of course the iron steps, you can say. Okay, so let's just determine the internal plaster. So we have number 6, and that is going to be internal plaster. We will actually determine the parameter of the wall, and then we will actually multiply that with the height of the wall, so we can have the internal plaster. Now, what should be the internal plaster? The internal parameter can be determined, okay? And the height, that is of course just 4. We will take 4, okay? Just ignoring these 3 inches height, okay? That is very small work, so we will ignore that, does not matter. So a number that should be only 1, because we have one, you can say, manhole, right? Now, the length, if you determine the perimeter, actually, we have 3 feet, you can say one side of the rectangle, and 3 feet the other side of the rectangle, which actually becomes, let me just write this thing over here, okay, so you guys can understand, which becomes actually something like maybe 6 feet, okay? And then we will add actually the other side of the rectangle, okay, the internal portion, you can say, and that is 2.5 one side and 2.5 another side, so it becomes 5, right? So this is actually the, you can say, the parameter, which is 11, and we will actually multiply this with the height, which is 4, okay? So what becomes actually this thing is the 4 times 11 times 1. This is 44 square feet. You can say SFT, because we determine the plaster work in CFT, sorry, in SFT, okay, or maybe in square meter, in square yard, okay, because this thing is just determined in terms of area. Another thing which is actually number 7, and that is the final thing, we have iron steps. A direct quantity, you can see that from the diagram, it is like maybe 3 iron steps, okay? And in the description, you can even put like maybe 3 steps, and you can say at 12 inches center to center, okay? So we have 3 steps is overall. You can see the quantity is 3. So I'm gonna say numbers. All right. This is the total estimation. Is there any question? You may ask if you have any question.
No, sir.
चलो, कल हम इंशाल्लाह स्टार्ट करेंगे प्रोजेक्ट को, ठीक है? तो आप लोगों ने ज़रूर ज्वाइन कर देना है, और मैं इस चीज़ को शेयर कर देता हूँ आप लोगों के साथ, तो आप लोग फिर इसको स्टडी कर ले। अगर कोई क्लास लिप करना चाहते हैं तो प्लीज़ आप लिप कर सकते हैं।